So we're going to be looking at changing a PDF to a CDF. Currently, the piecewise function that we have up the top is going to be an ordinary probability distribution function. If we find the area underneath that curve between 2 points, it will be the probability between those 2 points. The cumulative, on the other hand, if we put a value into it, or if we are thinking about it in terms of what a particular value means, it's going to be the probability up to a specific point. We'll look at the definition that's worth remembering, but to be honest, quite easy to remember because it just makes sense with the concept. Is the integral between negative infinity and x, which is a general point. Typically, if we integrate up to a point, let's say 2, we'd be finding the probability up to point 2. But we want to have a function that will allow us to, not have to go through the integration every single time. So we put a value of x in general to see what happens to like any value that we might put in. And because it still remains a letter, we give it this, it becomes a function, basically. And no longer do we need to integrate, we just substitute. So there's a plan, everyone. Now I'm going to put the plan into action with a little mini plan again. Maybe I'll get some more space. I'll do it on the left-hand side. So what we're typically looking for here is a 4-part that's going to begin at 0 and end with 1, because all cumulative distributions will keep summing, and by the end you should be at 1. Now, our aim is to turn each of these sections into functions that if we substituted a value in, it would give us the cumulative probability up to that point. So let's focus a little bit here. So before the start of this, so when x is less than 0, it's going to be 0. And by the end, when it's above the 2, we should end up with 1. Put a couple of holders in for where we're going with that, and I think it's always good to draw a little diagram to see what's going on. Yep. And in this case we have something going on between 0 and 1, which is a straight line because it's just a number, so that's going to go to about there. And then from 1 to 2 we have a straight line function which is steadily increasing, which we may as well put there. And remember, this is only a sketch. It kind of gives us an idea of what we're doing to give us, bearing. We could label that 2/5. I think it's 2/5. Yeah. Okay, so bearing this in mind, we have 3 sections. We've got this section before here, which is A. We've got the section in the middle, and this one here. We've got 4 sections, because with that last one there, remembering that on a CDF, actually it would be up at 1, but let's start with a different color for this first section. So we'll go with yellow, and we're going to focus on B. Now the definition is we want to find integral up to a general point like this. So that's going to be defined more specifically like so. We split it so that we have the integral between minus infinity, we can do better than that, can't we? And then up to 0, which is where this section B starts, of some function which we know is 0 anyway, but we're just going to put there as a placeholder. And then we're going to integrate between 0 and x in this function area B, which we know is 2/5. So this is the setup. Basically, if I'm going to find the area up to this point, from the left, I have to integrate this section, and I need to add what came before. That would be everything to the left. So that's what this bit of notation denotes. We know that this is 0. And we're going to integrate this. Now, here's where maybe you might want to take a detour away from what I've written here. I don't tend to generally do this, but I know some people would prefer it. Just keeps it kind of neat. Instead of integrating with respect to x, we generally just switch out any variable with t, because we're about to substitute the value of x in, and some people prefer when the variable is t. We'll see it again later, and I'll show you what happens. At the moment, we only change this. So it's going to go in, and you see, now this is going to add t rather than x. Did not plan it. This is just what people have been doing for a long time. And then we'll tidy this up. We're going to put the x in this time. So 2/5 of x, that's the substitution. And we're going to put the 0 in. And finally, we have 2/5 x. This is the cumulative function for section B. So if we ever wanted to find a cumulative value within that section from 0 to 1, we would substitute into this function down here, and that would allow us to bypass this integration stuff, which put it straight in, and it will give us the correct value. So we can fill that out here. It's going to be 2/5 x, and that's where x is between 0 and 1. Okay, so with the continuous functions, it's really great. The inequalities are not as precise. They don't need to be strict. More than is the same as more than or equal to, so it's useful. Okay, looking at this now, we've done section 1. Let's do section 2. This is the more interesting part, I think, but it's still the same ilk. Time for pink. So with section C, we're integrating up to a specific point, is here. And just to remind, this generic point here is going to have to cover everything from 1 and to x, plus everything in the previous section from 0 to 1, plus everything before that. Okay, so we've got 3 sections to take into account. So what's that definition look like? Integral between, so this is the actual definition, right? And what I'm about to write is the interpretation. The interpretation is that we first have, and this is the long-winded bit, but take your time. It's kind of fun in a way to do it properly and then see it. Looks neat, and it looks technical, actually, I should probably say. All of everything in that section 1, which we know has a function of 2/5. And then finally, we're going to integrate in the new section up to x of the function we have there, which is 2/5 x dx. Okay, fab. Running out of space, wouldn't want any more. That's just about enough. Looking at what we have, we know that this is still always going to be 0. And technically, this next section is a cumulative function. We have the cumulative version here at the bottom in yellow. We've found it. So we can just put in 1 into the cumulative, because that's the end of that section, and that should give us everything up to that point. And we're going to add the let's do this again. Some people use this as t, right? So instead of x dx, they would write t dt, and it doesn't change anything with what you're about to do, because x is going to come back in when you substitute, but it keeps, I suppose it makes sure that you've replaced it. So let's go ahead. T squared and 2 over, should we do that? Let's do that. T squared, and then that would be 2 over 10, which is 1/5. In other words, a half, isn't it? It's half of 2/5, which is 1/5. And we still have to put x and 1 into that. So in the background, we don't need to write 0. In the background, we've got f of 1. If we put 1 into there, that gives us 2/5. Maybe we should put that as a placeholder. Then we can see where the numbers are coming from. So if we put 1 into our cumulative function, we get 2/5. And over here, we're going to just like carry on, put the x in. So we've got 1/5 x squared. And we're going to take away when the 1 goes in, like so. And this is where I think this is where a lot of the problems come, is because we forget this bit here is going to interact with the 5th that just came. One last check before we carry on. Yeah. And so tidying that up, we get 1/5 x squared and 1/5 again. This goes into this section. I'm running out of space. Let's see if we can get it crammed in. X squared plus 1/5. And that's for values between 2. Yeah, that's up there. Yeah, so that's going to be including 2. Let's include 2. Put it somewhere. Just some finish error. Okay, so this is the main concept. When doing like the cumulative, it's really important to see it as everything that like happens before has to be added to this as well. Yeah,